Good morning.
Good morning.
Good morning.
Good morning.
So where is everyone in Joseph City?
Basketball.
Basketball
Wow.
tournament in Williams, and I don't know where Lauren is.
Lauren's in Las Vegas.
Lauren's in Las Vegas. Okay, so no Avery, no Jay, no Lauren, no Taylor, no Ricky, no Seth.
And Rebecca.
And no Rebecca. Don't want to forget Rebecca. All right, everyone in Holbrook. Anybody missing?
Everyone's here.
Everyone's here.
All right. Okay, so today today we're going to finish chapter 5. All right, and Monday we're going to do chapter 10. And so that's, and I'm going to just show you how to do all that on the calculator. So that's going to be a calculator day. Okay. Then Tuesday of next week, we're going to okay, so then what we're going to do is do any makeup or extra credit. Well, you know what? Maybe it'd be better. You know what? Let's do the chapter 5 test on Tuesday. Because then everybody supposedly will be there, okay, in class. And then on Wednesday, that's when what we're going to do is any makeup, quizzes, anything you want me to reopen. Wednesday will be our day. So anything to make up or second attempt, or the extra credit. I'll have the extra credit quizzes from chapter 5 open as well. Extra credit quizzes. Okay. And then Thursday of next week, and then the following Monday is our final. Okay? Any questions on what we've got going the rest of the way? So when will be our last broadcast?
Thursday.
Monday.
Wednesday.
It'll be Monday. Monday will be the last time you see me, okay? And then after that, you won't see me. You'll just be, probably swearing my name. No, hopefully you won't do that, but you'll just be working on testing and that kind of stuff. So you're gonna email me or whatever you want opened, especially on that Wednesday. Okay. Let's see. So Monday is the last broadcast. Now, is there any other questions about what we went over yesterday or Tuesday about the final or the evaluation or any of that?
How many questions are in each part of the final?
Let's see. did I put that? Oh, I didn't go through that. Okay. Yeah, these dates are wrong. Okay. So Thursday, December 12th, and Monday, December 16th. Yeah, it's on the Moodle, open book, open note, graphics calculator, no talking during the test, or I want you to turn off your phones even during the final. So each part has a 1 hour time limit, and there's 20 questions. And 9 of those are what I call quick hitters. So that's like matching, true, false, that kind of stuff. And then 11 multiple choice questions. Okay. And the emphasis really, I mean, 4, 5, and 10, really 4 and 5 have the most, chapters 4 and 5 have the most questions.
So, Mr. Strong,
Yes,
is the final questions throughout the whole year or just the
correct. For the whole semester.
Okay.
Okay. Now, and then next semester we start over. So it's not like when I was in school, our final exams in high school went from August through May, and that was a lot. But at least here we divide it up into the semesters, and we start over with all A's in January. Okay. All right. Anything else on that? So makeup work has to once you submit that part 2 of the final, it's over. You're done. Except the evaluation. Let's change that date. So that I'm allowing that to be done up until midnight. Now you could do the evaluation, the extra credit essay. You could do that tonight if you wanted to, but it's due midnight. Okay, and then let's see, 16, 17. So this would be the 19th.
Wait, what is the extra credit?
So
It's all in the Moodle.
what?
Is like the evaluation, is this all on Moodle?
Yes.
Okay.
And it's handwritten or typed and submitted?
What?
Is it gonna be handwritten or typed and then submitted through Moodle?
Are you talking about the extra credit evaluation, the essay?
Yes.
Yeah, that's got to be. Let's see. Okay, so yeah, it's got to be typed. 1 page, normal font, normal margins. And I'm gonna post all of these on the Moodle if it's not. I think it might be there already. I just was gonna update these dates. So you email me the essay. Normal font, normal margins, double space. Okay. And I would like you to put your name, the class, and then like Talent A or 11 o'clock, 152 or whatever, and then evaluation in the subject line. And then what I do is I give you credit for it on the final, but I actually don't read anything until after I've submitted grades. Okay. So I don't read the evaluations till after I've done the grades. Okay. But I went over this with you guys, right? We're just, hey. All right. Anything else? Okay. Well, let's So today we're going to finish chapter 5 and have you ready for that. Okay, we were just on practice 1, rewriting each. Okay, so why is this? Okay, I don't know what's going on here. Okay. All right, let's see. So can you see me and the board? Okay. So I don't know. It's kind of messing up again. So, but we'll just deal with it. All right. So I had asked you to do these 2 problems here for practice 1. We're rewriting using the properties of logarithms. And so this is the log of a quotient. So the first thing you do is rewrite it as the natural log of 2 minus the natural log of 25. All right? But we're not done, because it says to rewrite them in just terms of the natural log of 2 or the natural log of 5. So the natural log of 2, we're cool there. But see, this one, 25 is 5 squared. So if we rewrite this as the natural log of 5 squared, then what can we do with that exponent, with that 2? Bring it in front. That's right. I assume that's what that meant, right? Okay. Learning sign language. So, whoa. So that would be the final answer. Natural log of 2 minus 2 times the natural log of 5. All right. So the last one, how could we rewrite the natural log of 1/2? Anybody help me with that one? So using those properties of logarithms.
Well, I know that first you do the ln1 minus ln2.
Good. Okay. That's a great first step. All right. Anything else you can do to simplify that?
I don't know. I don't think so.
Okay. What's the natural log of 1? That was one of the things I had you write down.
Oh, yeah.
E.
It's E.
Yeah.
No? See, this is...
0.
It's 0, because this is log base e. So this is like saying e to what power is 1? And the answer is 0. And so this would go away. And so your simplified answer would be negative natural log of 2. Okay? All right. Any questions on any of that? All right, next, the change of base formula. Let's see, I think this is what's next. Okay, so the change of base formula says let a, b, and x be positive real numbers such that a is not equal to 1 and b is not equal to 1. The change of base formula says, so if you have log base b of a, then you can write this as a common log or a natural log. So log a over log b, or natural log of a over natural log of b. So you can use common logs or natural logs. So if, for example, if we had log base 3 of 5, then I could write this as log 5 over log 3, or natural log of 5 over natural log of 3. I would get the same answer either way.
So is log and natural log like the same thing, or?
No. Remember, just log is common log, that's log base 10. And then the natural log is log base e. Okay? So the bases are different. But see, these are the ones that have keys on your calculator. Okay? All right, so let's okay, so what would log base 8 of 20 be using common logs? How would I rewrite that?
It's the log of 20 over the log of 8.
Right. And kind of the way that I remember which one see it's this, you read this log base 8 of 20, and so when I'm doing the change of base formula, I just remember the base on bottom. So the log of 8 goes on the bottom. So base on bottom. Okay, and so then here, okay, rewrite log base 8 of 20 using natural logs. So what would that be?
Would that be natural log of 20 over natural log of 8?
That is correct. Okay. All right, now, what I would like you to do, here, I'm going to cover this up here. Okay, so now what I want you to do is to verify that those are the same. Okay, so let's grab your calculators. And I want you to put in log 20 over log 8. So the practice 2a. So put that in your calculator and get a decimal. Okay? Then, so write that decimal up here, the first one. And then for B, I want you to put this one in there. So natural log of 20 over the natural log of 8. And see if you get the same decimal. Okay? So anyone have any problems keying that in the calculator? Okay, so this change of base formula used to be so important when we would do these problems. But now, these new and improved calculators have a shortcut. So now I'm going to show you the shortcut. And so the shortcut is that you don't have to use the change of base formula. If you go to Math, and then arrow down, to letter A, where it says log base. Log base. And then you press enter, and then it just lets you put in the original problem. You don't have to use this change of base formula. So log base 8, and then arrow over, 20, enter, and that gives you the same answer that you got before. Okay, so whether you put it in as, so whether you put it in as log base 8 of 20, log 20 over log 8, or natural log of 20 divided by natural log of 8, you should get the same answer each time. Okay? Any questions on that? That little log-based key, though, especially with complicated problems, that can make your life much simpler. Okay? All right. Okay. So now, an application of logarithmic functions. Okay? So it says on the Richter scale, the magnitude R of an earthquake of intensity I is given by, so this is the formula. R, so that's like the magnitude on the Richter scale, equals log of I divided by I sub 0. So the I sub 0 is the earthquake that you're comparing it to. And so normally for the Richter scale, we compare it to an earthquake of intensity 1. So where I sub 0 equals 1 is the minimum intensity wave energy used for comparison. Okay? So in the formula, so the I sub 0 is usually going to be 1. So you might not realize this, but that the Richter scale is a log-based scale. So what that means is that it's the exponent. So like if you have, like usually an earthquake of like 7.1 or something like that, that is a major earthquake. That, kills people, does damage and so on to buildings and whatever. All right. I don't know, you guys might be a little young to remember, but I think it was in 2005. You might have heard of the tsunami in Southeast Asia. Any of you that just caused tidal waves and earthquakes and just major, hundreds of thousands of people died. Well, that measured like 9.1 on the Richter scale. Now, that might not seem like that big of a deal, but from 7.1 to 9.1, that's because it's on a logarithmic scale, that means it was 100 times more powerful than these earthquakes that just, destroy buildings or whatever. Okay? So like if you had a level 2 on the Richter scale versus a level 5, then see, this would be 1,000 times more powerful. Because again, the Richter scale is logarithmic. Okay? So let's go to the practice problem. It says find the magnitude R on the Richter scale of an earthquake of intensity and 68,400,000. Okay, so plug that in for I and see what you get. So you plug that into the formula I just gave you. All right, Hannah. What do you think?
Is it 7.835?
There you go. Good job. Any questions on that?
Yeah. So when you plug it into the calculator, if you do the math and you go to the log base,
Yeah.
you don't?
No, you do this one.
Yeah. See. Remember, if there's no base written, it's assumed to be 10. So you can just use the common log button, just the LLG button.
Okay, thanks. That makes more sense.
All right. Any other questions? Okay. So one of the coolest moments as I was teaching, as I've been teaching over the years, is one day we were doing things with logarithms in one of my classes, and I don't know if you've seen like like the map of a solar system. And and we were doing a table kind of comparing the period of the planets with their distance from the sun. Okay? And so you know how like here you have Mercury, Venus, Earth, and then there's a little space, and then there's Mars, and then there's a bigger space, and it seems like that there's no pattern. Okay? So then we actually graphed those points, the position of the planets on logarithmic paper. Okay? So again, we had the period, its distance around the sun versus its distance from the sun. And then when we graphed it, it was the coolest thing I'd ever seen in my life. Well, anyway, one of them is that all of the planets on a logarithmic scale lined up perfectly. And my mind was just blown. Because it's like, okay, so, the solar system isn't linear, but with a little bit of math, I mean, to me, it was so clear a result of, what do they call it? Intellectual design or something. Anyway, it was really cool. That's a cool application of logarithms. Okay, so that's it on 5.4. Any questions on that? So again, short section, as is 5.5. So let's go to that. Okay, so this is on exponential and logarithmic functions, kind of relating them. And really the big idea here is kind of where we started this chapter, and that's converting back and forth between exponential form and logarithmic form. That's really the key idea of this section, okay? So converting between exponential and logarithmic forms. Okay, describe some strategies for using the one-to-one properties and the inverse properties. Okay, so what this is, you remember when we were solving in 5.1, and we would say, okay, if we get the base equal to each other, then you can set the exponents equal to each other. Well, the same thing is true with logs. If you know that the log base 2 of x equals the log base 2 of 7, then it's like you get to cancel the logs and just write x equals 7. So those are what's called one-to-one properties. And so the inverse is like you get to cancel. So you try to get the base the same. All right, the second strategy is we also talked about where you rewrite exponents as logs and vice versa. So if you can't solve it written as an exponential equation, rewrite it as a log. If you can't solve it as a log equation, rewrite it as an exponent. And usually after one step of rewriting it, you're usually able to just put it in the calculator. Okay? But you have to know how to rewrite it. Okay, the third method we have not talked about, but it's where you take the log of both sides or exponentiate both sides of the equation. So we have not done any of those, so we'll go through that. All right. Anybody need any more time on this one? Okay. Okay. All right. So, to solve an equation like this, when you have a log, when you have your x inside the log, then what you're going to want to do is rewrite the log as an exponent. Okay? So you start with the base. Okay, what number up there is the base? 7. And what's the exponent on that? The 2. Because remember what the log is equal to is the exponent. So you say 7 squared is 3x minus 2. Well, so now we've gone from a really complicated looking equation to now this is an algebra 1 equation. Okay? So you square the 7, subtract 2, and divide by 3. Okay? All right? So now when you have an x in as part of the exponent, then what you want to do is rewrite that as a log. Okay? So this would be log base what? What number up there is the base? 3. So log base 3 of 11 equals, so remember what the log is equal to is the exponent up here. So it'd be log base 3 of 11 equals 2x minus 5. Now remember log base 3 of 11, that's just a number. Okay? So to solve this for x, we're going to subtract 2 and then divide by negative 5. And so this whole thing is what you would put in your calculator to get the final answer. So it'd be log base 3 of 11 minus 2. You probably put that in parentheses and then divide by negative 5 and you get the answer. Okay? I personally like to do that in one step. There are some students that like to, break it down to step by step, and it's okay either way. Okay? All right, next, to take the log of both sides. What does that mean? Well, now this you've never seen before. So you might want to write these examples, this one and the next example, just on the back sheet of the paper or whatever, because you've probably never done this before, and so a lot of times I tell you just watch the examples, but this one you might actually want to write down. Okay. So to take the log of both sides, you just do what that says. You just write log in front of each side. Okay? You took the log of each side. Now, so what does that do for you? Well, because it's a log, now you can bring the exponent in front. Okay? So that's one of the powers that log has. So then it's 3x minus 1 times log of 5 equals, okay, then you bring this exponent in front, x plus 3 times the log of 2. Now remember, we're trying to solve this for x. So now we distribute the log 5 and log 2 through each set of parentheses. So that's going to be 3x log 5 minus log 5. Distribute the log 2 now, so x log 2 plus 3 log 2. Right now, remember, we're trying to get the x's together. So we get all the terms that have x on one side, all the terms that don't have x on the other side. So 3x log 5, we're leaving that where it is. The x log 2, we're bringing this over to the left. Log 5, we're moving over to the right to be with the 3 log 2. Okay, we're almost done. So remember, we're trying to solve for x. So every term that has an x in it, you factor out the x. So you have x times 3 log 5 minus log 2. And now you divide both sides by that. 3 log 5 minus log 2. And 3 log 5 minus log 2. So then x is going to be equal to all of that. And so that's what you put in parentheses. And the numerator and the denominator, put it in your calculator, and you'll get some answer. Now, if you want to, the exact answer is all of this. But usually they'll have you put in your calculator and get a decimal approximation.
So, Mr. Strong, when you
Yeah.
have your 3x log 5 minus x log 2, why
Yes.
couldn't you just, add them together? Add,
Because they're not like terms. Remember, you could add, let's say if it was 3x minus 2x, you could combine those. But see, these log 5 and log 2, they're not like terms.
all right.
So you can't say you have 3 of them minus 1 of them. Now, if you had 3x log 5 minus 1x log 5, then yeah, that would be the smart thing to do.
The number after the logs have to be the same to add them together?
Yeah.
All right, then. Thank you.
Now, the other thing you could do is you could actually, you could put this in your calculator. 3 times log of 5 and get a number, minus log 2 of x, and then subtract and then divide. But that's really what you're doing here. So, you could put it in your calculator earlier if that helps you. I just like to do it all at once at the end. But your idea is a good one. Okay, so that's taking the log of each side. All right, so now the last method I want to show you is exponentiating each side. Okay? So here, it's kind of like, what you're doing is you're taking e, right, and making each of these as exponents. And so e and the natural log cancel, and so you get 2x plus 1 on the left. The e and the natural log cancel here, and the 7 comes down there, and then you just solve it from there. Now, I always have students that say, well, can't you just, if you have a log on each side, can't you just cancel the logs? Because that's kind of what's happening here. And mathematically, that's not allowed. But that, in a sense, that's what you're doing. So if you have the log of A equals the log of B, you can just kind of cancel the logs and say A equals B. Because it's this exponentiating thing that makes the logs go away. You're not actually dividing each side and canceling. But it works. It works. Okay, so now using those methods, what I'd like you to do is do practice 1. So all 5 problems. They're all kind of mixed in. So let's just see kind of what you know, what you remember, what you can figure out. All right, so Andres, when you've got the first one, or if you need help, let me know.
Okay, I might need help on this one, but
Okay. Go
eight
ahead.
8 to the power of 1/3 equals x.
Oh, you got it. So now what's the cube root of 8? So remember, 8, the 1/3 power means the cube root. So what cubed is 8?
2.
2. So the answer would be 2. Okay. All right. Any questions on that? So the method you used there was just rewriting the log as an exponent. And so now if you didn't remember about the cube root thing, then you just put that in your calculator. 8 raised to the 1/3 power. All right, Caitlin, when you've got B.
She's not in the room right now.
Okay. All right. You want to volunteer as tribute?
Yeah, I can.
Okay.
Give me a moment. I got -2.
-2. Good job. Okay. So there, so what I did here is rewrote this as a log. So this would be log base 5 of 0.04 equals x. And then you just put that in your calculator. Okay. Any questions on that one? Okay, so here's the sad thing for me. I mean, I think these are easy questions, but you kind of have to have somebody show you how to do it. Okay? And so I feel sad for those guys in Joseph City that aren't here today, because a lot of them aren't going to be here on Monday either. And so they're going to miss all these easy questions. Okay? Unless Jill or Kinsley helps them out. So, I don't know. Anyway, it's kind of sad. When you miss the last couple of days here at class. Okay, so let's go to the next one. All right, Madison.
I need help with this one.
Okay. All right, so probably what I would do is get the E part by itself. Okay, so add 7 to each side, and so then you get that. All right, now, okay, let's, so the variable is up here in the exponent. So when that happens, what you want to do is try to rewrite it as a log, okay? So when the variable is in the exponent, rewrite it as a log. When the variable is in the log, rewrite it as an exponent, okay? So what would this be in log form? So log base, what's the base?
E.
E. So log base E, that's natural log. So ln is log base E. So log base E, or natural log of 66, equals the exponent, x minus 2. And so then, to solve that for x, what would you do?
Add 2.
Add 2. So you put that in your calculator. Now, is that the same thing as the natural log of 68?
No.
No.
No. You do the natural log of 66 and then add 2 to that. Okay, so go ahead and put that in your calculator and tell me what you get.
I got 6.189. 6,
Excellent.
7.
Okay? Any questions on that? All right. All right, Jocelyn.
I need help on this one. I was a little confused on what to do.
Okay. You see how they both have log base 6 on each side?
Yeah.
Okay. So you get to cancel that. So if you have the log of A equals the log of B, then A equals B. Okay? So mathematically what you're doing is that you're taking your what's called exponentiating. So you're taking 6 to each of these, but then the 6 and the log base 6 cancel. And so you just get 4x minus 7 equals 8 minus x. So you're allowed to just cancel those logs as long as the base is the same. Okay? All right, so now, Jocelyn, see if you can finish it up.
Equal 3.
3.
Oh, I added wrong.
There you go. So if you had 2 to the 3rd equals 2 to the x, then x is equal to 3. So if the bases are the same, you get to cancel those. Or if the logs are the same, you get to cancel those. Okay? Any questions on that? Okay. All right, Serena.
I need help on this one.
Okay. So the first thing I would do is get the log by itself. So how can I get rid of the 4?
Divide it.
Just divide it.
Oh.
Okay. All right, now what? So if the x is inside the log, then what do you do to get it out of the log?
Divide. No. I don't know.
Can anybody tell me?
Say what again?
If your variable is inside the log, how do you get it out of there?
You subtract it. You do the exponentiating thingamajigger.
Yeah, or you rewrite it as an exponent. Okay. So what if your variable is an exponent? Rewrite it as a log. If the variable is in the log, rewrite it as an exponent. Okay. So So if we're going to rewrite this as an exponent, then what's the base here?
E.
E. Very good. You did that with ease. Huh. Okay. So e to, what's the exponent?
That's why I laughed.
7.
E to the 7th equals 5x. Okay, here, let's see. Let's do it over here. So you get e to the 7th is 5x. So now, solve for x, divide each side by 5. And so that's what you put in your calculator. E to the 7th divided by 5.
Okay, you feel better.
219.
219?
Okay, I didn't plug it in.
219.3266. Good job. Okay? Now, with all of these, they're all equations. So, how can you check to make sure that you get every one of these right on the test or the final or the quiz?
Plug it in.
Plug it in. Plug in your answer and see if it works. Okay? All right. Well, okay. So the last thing, we've only got 3 minutes here, but we can do it. Okay? Remember we used the PERT formula. So it says use the formula for continuous compounding, A equals PRT, to find out how long it will take $1,500 to triple in value if it is invested at 12% interest compounded continuously. Okay? So if you start with $1,500 and it's tripled, then how much money do you have? Let me say it again. You start with $1,500. You're tripling your money. How much do you have?
4,500.
4,500. Okay? So you end up with that equation. Now, the first step in solving this equation, you want to get the E by itself. So divide each side by 1,500. And so 4,500 divided by 1,500 is 3. Okay, now this is the big idea here. You actually didn't even need to have the 1,500. If it just said triple in value, see however amount you have over here, you'd have 3 times that. So to triple it, it's just 3 equals e to the RT, or double would be 2 times e to the RT. All right? So if we drop out, finish this. But did anybody have the answer before we drop? So it's how long it's going to take. So we're solving for t.